ahead and start. Thank you, everybody. This is such an enjoyable meetup. This is the Open Research Institute's FPGA meetup for the 11th of June, 2024. And what we do is we talk about what we have done, what we have planned to do, and what we need in terms of resources, and if we have any roadblocks we need help with. And just we share this meeting. It's recorded and posted for anyone to see, and we accept folks where they are and try to get them doing this really fun stuff that we do. Digital communications is amazing, and FPGAs are awesome. Difficult, can be frustrating, but well worth the effort. So thanks everybody for being here. So this is a view. This is documentation for Matthew. This is the minimum shift keying top level diagram, and this is possibly a little bit stale, lagging a little bit behind some new interface signals and all that. But this is the basic idea. So at the top level, you have a modulator and a demodulator, ins and outs, things like that. So when we talk about the MSK, we're talking about a minimum shift keying transceiver for Opulent Voice or other uses, but we're going to deploy it for Opulent Voice, our uplink protocol. And what we're trying to do now is since we've got good traction on some good results with this HDL, then we're trying to stitch it into the HDL reference design for the Pluto first. So we're trying to get it to fit. And I went ahead and drew this just to make sure that I understood how we were hooking it up. So the things that are in blue are the things that don't quite match yet. And there's one missing signal that we talked about on Slack. So I took the receive and to transmit, kind of broke them out into two separate things. And then this is Matthew's work. This is just how the reference design handles things with the direct memory access and the UPAC, how it rearranges or organizes the I's and Q's going out to the 9361. And you can see that the one transmitter, the 0 transmitters, there's all the way over there on the right, there's a I0, Q0, I1, Q1. The 9361 actually has 2 transmitters on chip. Well, I've always thought of it as the Pluto only having one of the transmitters available, but we learned a little bit about that. But only one of the transmit chains has the transmit interpolator hooked up to it. They mean for you to use the 0. And then this is where we would like to go. This is Matthew's drawing about, we might be able to eliminate the UPAC or eliminate some of these, eliminate the interpolator, maybe take over some of the functions of UPAC to kind of reduce the so-called parts count. And so this is kind of where we're trying to go. And as you can see, we only really deliver data to I0. So here's the kind of the tightened up proposal for how to stitch our IP, our intellectual property, into the reference design, and then remake the project, because it's a make file that produces sort of the artifacts, the things that we need in a bit file in order to go ahead and reflash the firmware on the Pluto. So exciting stuff. I tried really hard to try some of this morning, but ran out of time. And then a little more detail about the second transmitter connections on the Pluto. This is from the schematic. There actually are some U.FL connectors for the second transmitter. It's rumored, but it looks like you actually do have to do some work in there to get a second transmitter. So kind of exciting. I've always been told, and I assumed. I mean, I've looked at the schematics before myself, but I missed this totally. That there's actually a lot more in there for a second transmitter than we thought. This is a photograph from the University of Puerto Rico for our Opulent Voice implementation for them. You can see a little Pluto there on the bottom left and the amplifier there on the side of the box. And they're coming along. They have some questions about getting enough power and making things work. They're at the point where they're testing the transmitter. They've passed all of the milestones with NASA for the Wallops launch in August. And this is my attempt to have a video in a presentation. So what I'll do is I'll post this separate
Roxat X, Roxat X, Roxat X 2024. This is a recording made by the students at the University of Puerto Rico, which is being transmitted in the Roxat X 2024 rocket using Opulent Voice as a modulator. Opulent Voice is an open-source high-quality voice and data protocol designed by Open Research Institute for use in amateur radio. Apart from this radio experiment, the payload also includes environmental sensors capable of measuring humidity, temperature, and pressure in an effort to better detail the upper atmosphere. Additionally, we're including cameras which will be used to create a virtual reality experience as an outreach tool. This is WP4PQI, Whiskey Papa 4 Papa Quebec, India.
So that's the recording that's going to play over Opulent Voice from the rocket. And I'll make sure that goes into our recording. So I'll stop talking here, and then I'll turn it over to Matthew to expand and correct on any of this, or and to let us know how things are going.
Yeah, I think that was a good overview. I made the updates to the top level for the TX that you showed in the previous diagram. I'll like 3 more down. 1 more. Yeah, this one. So these updates are all into MSK top. So we have the AXI S interface. It's there, and the TX enable and TX valid are coming in as well. I've taken the TX valid and just used it. Well, it's no connect at the moment. The open question here is if it's, so there's some circumstances in which it's high all the time, you can ignore it. And there's some circumstances where it toggles to indicate that it's accepted a sample. If it's high all the time, everything's good to go. If it's toggling in our particular use case, I need to add some clock gating into the design. But other than that, this is, oh, and then so we have a 64-bit bus coming in. You can go to the previous slide. So what we're doing now, we see the A0, A1, A2, A3. We're just taking it's configurable in a register to say how many bits, but it's just going to take the LSB up to the number of bits. So this could be packed as A0 through that whole column instead of the B0, C0, D0. But right now, I'm in my simulations, I'm configuring the A0 to 8 bits. So even though I'm getting 64 in, I'm just taking that the low 8 bits, and then just shift, there's a shift register to take each bit, or a multiplexer to take each bit in order from the LSB to the MSB. And then it does the modulation, and then we're putting out 16-bit samples now. It was 12 previously, but I may still make it 12. But the resources aren't that critical if we're using the DSP slices. And then so S0 would correspond to, well, the first bit of A0. So that's not exactly clear, but the coloring is meant to just show that the samples are coming from the A0, A1, A2, A3 data coming in from the DMA, and then we're just applying it to the I0. So this path should be completely ready to go. My simulation right now, the data rate is 15.4 kilobits, and I have an IF. The IF has to be 4 times the data rate, or it has to be a multiple of 1/4 the data rate, so that the zero crossing of the IF in this case is matches the zero crossing of the symbols. So, and then I'm running it with the sample rate. Oh, well, I'm still looking at that. The sample rates. I'm trying to determine if we need an interpolator. There's really no reason that we need an interpolator. We just highly oversampled, but there's no accumulators or anything in the modulator that should particularly require an interpolator. So I think we should be able to get rid of it. But but I just need to run some more simulations. So right now, I'm running a bit rate of 54,200, a IF of 10 times that. I meant to run it 20 times. Oh, and then I'm running a sample rate of 1/8 the 61.44 megahertz. So I'm going to run some more simulations. I slowed it down just because there was some funniness happening, but I need to go back and rerun it. So there's some possibility that we'll want to put the interpolator back in, but I'm just trying to save the space if we don't need it. So yeah, we just sit here between the MSK and the AXI block. So that's it. I think on the modulator, like the AXI interface is there and working. I'm simulating it. Oh, and then on the next page, so I'm just kind of going through this really fast, I know, but the enable signal, I'm just gating with the synchronous in it. So basically, if the enable's off, we're just turning the modem off completely. And then when the enable goes on, the modem will come on. And there's I didn't show it in this diagram, but there's a AXI4 Lite interface for some configuration registers. And I have a PTT bit in there. If we need to put it somewhere else, that's fine. But right now, it's in a configuration register in the MSK top.
Yeah, very good. And what your suggestion from Slack was to go ahead and hook this up and work to try to demonstrate the transmitter, and then the receiver side still needs a bit more work, I think. But we're going to go ahead and try to test the transmitter.
Yeah, and the receiver simulations, I had a PRBS on my test bench, which was not matching, but I have just an XOR in the top level that I'm also looking at, and there were a burst of bit errors a little bit into the simulation, likely due to the timing loop stabilizing, but it was clean after that. So I think the RX is actually in pretty good shape too. It has the correct interface for the AXI A to D 9361 block. So it should hook up to that. And I think based on your diagram here, the other side to the TXU pack, again, I don't think we need the TXU pack. It should be able to just go straight to the FIFOs. And so we have the TX samples. I'm sorry, we have the so the CPAC, I think we can probably drop the CPAC, and so the ARC samples would go to the FIFO, and then there's a valid signal with the samples that would be the right signal, the FIFO right. Yeah, on the right side there, I see it. So there would be a 63-bit bus coming out of the out of the receiver. The low 8 bits are going to contain the data. So it's very much the opposite of the transmit, but I'll generate the diagrams as I have some time. But so it may work, but it may not be there too.
Yeah, I think what we'll do in the lab is that when we get things stitched in, I'm just assuming that like a loop back would be a good idea, because that would probably match what you're doing with your test bench. And then with a little bit of competence, then we can actually duplicate your test over the air. So that'd be kind of nice. Or over conducted link.
There is a digital loop back inside the top MSK top, but so we could do that in certainly the analog loop back. But if we're not getting good analog, we could still try the digital loop back and see.
Okay. Yeah, to see where the problem is at least.
Yeah. And so here the decimator, we might need the decimator here because in the Costas loops we do have the accumulators. And so those accumulators, if we're 60 plus times oversampling, those accumulators could get pretty large. So the decimator might be helpful in the receive path. I think, if we're using the DSP slices, even if they get large, I don't think they'll get 48 bits large. So, if we wanted to save the resource, we probably could. So that's kind of an open question. And then the same thing with the valid signal coming from the A to D interface, whether it's toggling or not, we need to make sure we understand that, because we'll have to add the clock gating in the receiver if it's toggling. So, but I mean, I think it's pretty close. I'm pretty excited about it.
Yeah.
I've been trying to also update all the code and put headers and copyright and licensing in there so that we can, at some point in the near future, put it in a GitHub repo.
Yeah, I'll be fetching your repository over to the Vivado project in order to export like the component XML file and then move that over to the library block. And so at that same time, I'll take a look at it and see if it looks good, which I imagine it will. And then yeah, it'd be really nice to get this in a public repository. So right now, if you're curious about where the code is, it's on ChocoCat in a Git repository that we've been synchronizing to. So not accessible, not on our usual ORI repo collection quite yet, but it will be there soon.
Yeah, and I just wanted to break out the NCO and loop filter as separate components to be library components.
Yeah, I think that's a great idea. Like even if like each significant component has its own repository, I think that's a really good way to do it. I've often wanted that myself, looking for components to find something. Like you find a design, but it's all real, even if it's broken down into files and modular, it's still one giant file and may have lots of scripts and things, and lifting out a component that's useful can be kind of feels risky, or it's a lot of work.
Yeah, I mean, I think having a modular design library for, oft-used components is really helpful.
Very.
And it just now occurred to me, maybe another thing that might be helpful or useful is, I don't know if the Simulink model would be good, but I could probably make a GNU radio model to put in those same libraries. So then you'd have something you could drop into GNU radio with that would model that particular component as well.
Yeah, I think it'd be very useful. Any models that we might have to help people, because we want it to be useful. We want it to be useful, yes, but also easy to use. And I think anything that we can do in terms of documentation or working models would be deeply appreciated. I know GNU Radio is a contender for that. And yeah, Simulink models too. That's a good one. Those are, so I think that probably covers a vast majority of the potential audience that would want to use models for these components. So I'm in favor. All right. Anything that we missed, Matthew?
Not that I can think of. I'm just
Okay.
looking forward to this. It's pretty exciting.
Yeah, it is. No, I'm stoked. This is great. Thank you so much for a lot of very competent and hard work. It's been a big learning curve for everybody, but a good one.
Yeah.
Okay. And then let's see. Ken, you have quite a bit to report on Haifuraiya on the receive side for the project.
Hi there. Let's see, working with Michelle, trying to get the Linux compiled. We got it booted up on the ZC 706 target yesterday, and I guess the next goal is to figure out how to bring the parameters for the radio chain. We've decided on going with you can't quite build the radio on the ADRV 9009 using the traditional 15 kilohertz spacing that LTE kind of builds up on. which implies a certain clock rate and so forth. It looks like the closest thing we could do is start with a 20 kilohertz building block, and I think we settled on 320 kilohertz as our kind of fundamental unit for the FFT. So that'll span. You get almost 64 channels in it, or almost 64. I guess let's call them frequency bins in a 20 megahertz allocation. So if the receiver can implement if you give it 20 megahertz, you'll get most of you know that you're going to meet the Nyquist with, and that's also what we require with our polyphase filter, a 2x oversample coming into the input. So we've set it up so that basically it'll be able to feed that structure. Yeah, up to 20 megahertz will work, and if we need something like a guard band or a roll off factor or something, then we can basically, it's we can support that. So yeah, there's a lot of different restrictions that the ADRV 9009 has in terms of the minimum bandwidth and and what it needs to be as a fraction of the sample rate and so forth. So it seems like this is the best trade-off. I think it's really the 9009 is a little more geared towards even wider bandwidth designs. So we kind of have to work within, as you bring it down to the 20 megahertz range, there's a variety of restrictions that get close to the minimums, but we've got something that at least builds. We just need to plug that now into the framework. Basically, it's a radio configuration, and we have the bit file that has polyphase input. So in theory, we're pretty close to being able to feed samples, live samples in. So that's about it.
Yeah, thank you. Lots of moving parts. It's the process of booting up Linux on a targeted on a Zinc chip with the ARM in there is kind of non-trivial. So this is a really nice step to take to see all that work. We had to debug the usual problems, reboot the target in the lab a couple of times, and it worked. So here's the proposed channel plan, and there's right off the bat, there's two ways to do it. Right now we have 320 kilohertz channels, which is pretty big, lots of room. Our 81 kilohertz Opulent Voice signal in there. You can see it represented graphically. It kind of shows you how much. And we can also have much narrower channels, 160 kilohertz, if we go to 128 the polyphase with 128 channels instead of 64. But we're starting out with 64. So we're expecting to see this signal in the lab and test it out. So this shows you like where are we in the allocation chart. So our amateur satellite uplink frequency allocation at 5 gigahertz is from 5650 to 5670, and we are going to go ahead and take up all of that and kind of round down, I suppose. So we'll lose a couple of channels. We can also expand past it. This is a voluntary sort of channel map or band plan. We have plenty of space at 5 gigahertz. So, we talked about this and decided that we go ahead and comply with the 20 megahertz. And that's what you're seeing here in this particular document. So this is over in the FPGA channel on Slack. And so that's the summary. So hopefully over the next week, the plan is to go ahead and show that this channelizer is working and can successfully pick up channels over on the 9009. And these channels will be filled by the Opulent Voice signal and possibly other signals. We can do some fun things with just passing along signals. So we're in a position where we could recognize our opulent voice, demodulate, decode, do things with that. And then if we detect energy, but we don't know what it is, then maybe we just sample it and pass it along as a experimental channel, something like that. We've talked about different options in the past to be flexible with so where we treat our own native mode a little bit differently, but don't necessarily ignore all other energy. And then, as you can see from the authentication and authorization discussions, that does kind of open us up to jammers. And Tilak has spent some time looking at that. So this is a good opportunity for like signal recognition. Like, oh, that's a QPSK signal or a BPSK signal or something like that. That maybe that's legit, and maybe if we could discriminate between different types of signals, this would give us an opportunity to have to demonstrate that sort of thing. Okay. So Paul, you have the floor. Tell us about the lab.
Well, congratulations to all three of you on some great milestones and good progress this week. Just to even things out, I've made no progress this week, so got very little to report. The lab is still working.
No, that's very good. Thank you very much for taking care of things. You've helped out over the past week for sure. So I think the last time we talked was about the Viterbi decoder oscillations or perturbations that we were seeing. Is there any additional follow-up on that? Did we like thoroughly report all of that last week?
I think we covered everything that we understand. Still unclear whether it's expected behavior or something wrong. I haven't done any further investigations since last week, I don't think.
Yeah, I haven't either. I think my action item was to dig in and see, do we need to make any adjustments to like the look back length? The way that decoders work is that they accumulate these branch and path metrics, but at some point you have to kind of stop and then make a call and say, here's what I think I got. And we've made some changes from the original the base design or the inspirational design, and we haven't changed. I don't think we changed the look back length, and from memory I think it might have been 40. So my instinct is that we might need to lengthen that because we're now dealing with longer frames. But we'll see. This would be a really good thing but once we do have it kind of working over the air and we can get a quicker loop on metrics and like make some changes and say, okay, so we're gonna run it this way and then we're gonna run it that way and then look at the difference. If I had I think a slightly better grasp on like the repercussions of changing this, a slightly better grasp on the theory of this particular error correction, I might be able to make the call today, but it's working decently well the way that we have it set up. And but what we will be looking for is ways to optimize it, just like that we optimized some of the other aspects of the protocol. So this is definitely on deck to investigate. So thank you very much for the great graphics and all of the picture being worth 1,000 words. It really kind of brought this quality of the digital protocol to life. Yeah, and no complaints. The lab's working well. Thank you. All right, any other comments or questions or any resources needed or anything before we close down office hours?
I just had one comment.
Sure.
So I don't know if we're gonna have any more discussion at some point. I had posted a proposed, kind of dev board and put it in the FPGA area. So if anybody
Yeah.
at that or has any feedback, that'd be great.
Yeah, sorry for overlooking that. That was definitely a big thing over the past week. So yeah, it's a proposal, like a workbook proposal. So I think that's an FPGA. for
Yes.
modular approach to, backing away from using all of this big iron frameworks and dev boards and profiles and all that. So yeah, please, if you're listening to this and you haven't already gone and taken a look on the proposed approach, please do, and I'll spread it around a little bit more. And maybe next week we can feature it and talk about it, go through it, hopefully get some feedback between now and then, and expose it.
Yeah, it
So
might
yeah,
be worth.
thank you.
Sure. Might be worth talking through a little bit, just if there's things that aren't clear.
Yes. Yeah, thank you. All right. Thanks, everybody. This is fantastic. Great work. It's a privilege and an honor to work with all of you. And see you on Slack and next week.